Okay, in this video we're going to be reviewing how to do for loops in MATLAB. Alright, so first of all, what is a for loop? So a for loop is an index programming construct that allows us to repeat a set of programming statements. Okay, and so those two words are kind of key. And so probably the one that probably people associate more with loops is repeat. Okay, and so there are a lot of times when you're programming when you want to repeat either an assignment or a computation many times. And so a for loop kind of lets us do it in a very convenient way. Okay, and so some examples of when you would use a for loop for MATLAB is, let's say that you're assigning entries in a vector or matrix that follow a certain pattern. Okay, so let's say you have a very large matrix or very large vector. You can do a for loop to assign its values very easily. Okay, or maybe you want to compute the value of a function at different locations, or maybe using different data sets. Okay, so a loop will let you do that. And so some of the characteristics of a for loop is that, before you even start, the loop has to know how many times it will iterate. Okay? And the number of times the loop has repeated is tracked with something called an index variable, which we'll go over very soon. Okay. All right, so here's what a for loop looks like in MATLAB. And so I'm using just kind of generic names for these, but or for all the variables here, but we're going to go through one by one. Okay? All right, so first I want to highlight here is the loop index. And so this is a variable that you kind of define within the for loop that you can use to track its progress. Okay. Next, you define the starting index, and so this is the starting value for that loop index. And then you define the stopping index. Okay. And so what's going to happen is that each time the loop repeats, or the number of times the loop repeats is basically the difference between stop, and start. Okay. And so traditionally, what most people do is that for start they put 1. And then so to make it easy for the stopping index, they just put the number of times they want the loop to iterate. Okay. And then inside right here, this is what's called the loop body. And so this is the code that's going to repeat. Okay. And so here I only have one line of code, but you can put as many lines of code here as you want. All right, so let's talk about the loop index a bit more. So the loop index is a special variable, and it's used to keep track of which loop iteration is currently on. Okay, and so just like I mentioned just previously, so the loop index starts with the value of start index, and each time the loop body completes, right, each time you complete all the code within the loop body, the value of the loop index goes up by 1. Okay, so let's say it starts at 1, the body completes, then the loop index will be 2, body completes 3, and so on and so forth. Okay, the loop will keep repeating itself, the body will keep repeating until the loop index exceeds the value of the stopping index. Okay, and so what you can think of as the last iteration of the loop happens when the loop index reaches that stopping index. Okay, after which we say that the code exits the loop. Okay, and the loop index is really valuable, not only for counting, of course, and keeping track, but you can actually use the loop index within the body of the loop. And there's a lot of really cool applications for this. And so let's do an example of this. Right? And so here I have a loop, and so I have this empty vector here. So I've defined this vector with all zeros. And what I want to do is I want to populate the entries of this vector according to this formula right here. Okay, where I is kind of the position of where we are in the vector. Okay, so this is the first position, second position, third position, fourth, and fifth. Okay. And so this loop is going to iterate 5 times because we've defined the stop index to be 5. And we're going to visit each entry in the loop. And so after you run this code, you should get the value of the vectors to be here, right? So 8, 11, 16, 23, 32. And they follow this formula here where it's I squared plus 7. Okay, so let's kind of walk through this loop and kind of go iteration by iteration just so you can see what's going on. Okay, so before the loop starts, the vec1 is completely empty, so we have all zeros. After the first iteration, I is equal to 1, okay, and so we plug 1 into this equation right here, and we get 1 squared, which is 1, plus 7, which is 8, okay? And so what we're saying is that vec1 in the first position, since I is equal to 1, is equal to 8, okay? Since the first iteration has completed, the loop, you can almost physically think about it as the code kind of coming back up right here, except now instead of I is equal to 1, I is going to equal to 2. Okay, and so when I is equal to 2, we plug in 2 here. We have 2 squared plus 7 is 11. And so we assign the second entry, okay, vec1 at I, to be 11. Okay, and then we just repeat this over and over again. Okay, and so notice how the entries of vec1 are kind of being built up. They're being assigned each time the loop iterates. Okay, and so I think when people look at a loop, I think they get a little bit intimidated because they think, they kind of look at the loop and they kind of look at the output like this, and they think it all happens at once. It doesn't all happen at once. The code literally, goes in, does the body, and then comes back up and then repeats, and it kind of happens all in sequence like this, okay? And so what I usually tell people is that, if you're confused about, if you're kind of getting mixed up with what's happening in the loop, just go ahead and expand it, okay? And so these two codes right here are identical, okay? And so they do the exact same thing, except I think people probably have an easier time reading this code if they're not used to loops, okay? And so you can see here that, we have these sets of code right here, the temp and the vec1 line. That's repeated because that's inside the body of the loop. The only difference between each chunk here is that we're setting I to be a different value, just like it was in the loop. Okay, and so if you're ever confused about what a loop is doing, think about expanding the loop like this so that you can kind of see what's going on the inside. Okay, so there's a few other neat things that you can do with the loop, and so one thing you can do is you can put an if statement in the loop. Okay, and so one of the primary reasons why you would do this is that you could tell the loop to do something different depending on the iteration. Okay, and so you can see here that I have an if statement on the loop index, and so when it's less than or equal to 5, and so for the first 5 iterations, we're going to assign a value of 6 to those entries. Okay, and oh, it's a little typo. This should have 10 entries. Okay, and then but if I is greater than 5, then we're going to assign a value of 9. Okay, and so you can see here that's the result where we have 6 in the first half, 9 in the second half. Okay. You can also have nested for loops, and so you can have loops inside your loops because, we heard you like loops, dog, right? And so if you do this, then the inner loop is going to do a full complete cycle each time the outer loop iterates. Okay, and so the analogy that I like to give people here is think about how an analog clock works, right? So each time the hour hand moves forward 1, the minutes hand would have to make an entire full rotation. And so if you think of the inner hand as like the inner loop and the hours hand as the outer loop, that's kind of how it goes, okay? And the nice thing about this is that you have 2 loop indices now, and so you can use those to whatever effect that you want. And so one of the primary ways that at least I use nested for loops is to assign values in a matrix. Okay, so you can have one index referring to the row, another index referring to the columns, and then you can use them in a formula just like that. Okay, and so when to use for loops, and so for loops are very useful. If you do programming to any degree, you're going to use them. And for loops are probably most valuable when you know how many times the loop is going to iterate. Okay, and so that's kind of the key to using for loops, that before the loop even starts, you should know, or at least you should have a variable that knows how many times the loop is going to iterate. Okay. But there are also cases, particularly in like interactive programming, where the program relies on input from the user, where you don't know beforehand how many times the loop will iterate. In those cases, you would best use a while loop, which is going to be the subject of another video.